to the InfoAg Learning Exchange. I'm Corey Rosenbush, President and CEO of the Fertilizer Institute, and we are excited to present this new webinar series, which aims to provide you with trusted information that will help you meet your business goals. For 25 years, the InfoAg Conference has been your source of information about the practical application of precision agriculture. But like many of you this year, we are navigating a new normal that impacts how we give and receive information. As we look at new ways to share, the Fertilizer Institute is committed to being a resource for you beyond the conference stage. The online InfoAg Learning Exchange helps us expand the conference as we seek to advance modern agriculture through data-driven solutions. But don't worry, the information you've come to expect is not going away. Building on InfoAg's strong history of educating crop advisors and ag retailers, we are looking at solutions for today's ag professional. Our content lineup is expanding to include a wider reach of tools, technologies, products, and practices that crop advisors can use as they serve their customers. This includes a broader perspective of solutions to support the 4R nutrient stewardship framework, using the right source of nutrients at the right rate, the right time, and in the right place. As the industry advances with new technologies and practices, the Fertilizer Institute is proud to be a resource for you. With that, thank you for joining us today. If you like what you hear, we are hosting an entire webinar series before InfoAg Live, which will take place December 15th through the 17th in St. Louis, Missouri. Visit infoag.org to see our webinar schedule and archive, and for more information about the conference in December. I hope to see you there. Before we get started with today's presentation, I'd like to thank today's Learning Exchange premier sponsor, EFC Systems, along with all of our series sponsors. InfoAg would not be possible without their generous support. And now I'd like to introduce today's moderator, TFI Senior Director of Agronomy, Dr. Sally Fliss.
Thank you, Corey, and thanks again to our sponsor, EFC Systems, who you will hear from after today's speaker, Dr. Raj Khosla from Colorado State University. But first, a few webinar notes. For the CCAs on the call today, the QR code for this course will be shown on screen at the end of the webinar following the presentation from EFC Systems. To get your credits, open the CCA app on your phone and point your camera at the screen. If you have any trouble with this, please let me know. My email is sflis@tfi.org. We will leave the code on screen for 30 seconds, so please make sure your phones are ready to go. On the right side of your screen, you will see a chat box, which you can use to talk to other attendees, or as some of you are doing, let us know where you're from and that you're with us today. Above the chat box, you'll find a series of tabs you can switch through. Please use the Q&A tab to ask our speaker any questions. We will publish your questions as they come in, and you can vote for which questions you'd like to see me ask Raj. Finally, there are handouts in the tab where you'll find some resources related to today's talk that you can download during the webinar. Our speaker today, as I mentioned, is Dr. Raj Khosla from Colorado State University. Raj is the Robert Gardner Professor of Precision Agriculture, and his main research focuses on the management of infield, soil, and crop spatial variability using innovative technologies for variable rate precision nutrient and water management. He works on a wide variety of innovative techniques and technologies to look at the diversity of soils, including using satellite-based remote sensing to create management zones, which is being used by farmers in Colorado and across the United States. He was one of the founders of the International Society for Precision Agriculture and has been involved with InfoAg since the beginning. So now we'll start Raj's presentation.
Thank you, Sally, once again, and thank you, TFI, as well. I'm delighted to be part of the webinar series, InfoAg Learning Exchange. Let's get started. I'm going to talk about nitrogen, its productivity, profitability, and sustainability, something that my lab and I have done at Colorado State University now for the past 20 plus years. So let's take a quick look at basic agronomy. We all know that when we plant seeds in the soil and provide moisture along with that and supplement the soil with additional nutrition and NPK, we expect a positive response for a healthier crop. Now, since we're talking about nitrogen, as we increase the rate of nitrogen application, we expect a positive crop response in increasing terms. Sounds simple, right? Well, why is it that in the 21st century today, we're still talking about the challenges of nitrogen? It is not that simple. Well, if there's one thing that could encapsulate how I feel about nitrogen and nitrogen management, I think this picture says it all. Managing nitrogen many days feels like we're pouring coffee into a cup that doesn't necessarily have a bottom. So there's a significant loss of nitrogen that happens by using this metaphor, right? What I really mean by that, if we look at the global nitrogen use efficiency today, we have actually gone down from about 70% in 1960s to less than 50% today. Now, this has significant consequence on environment as well as on our pocketbook. So what can we do? Why is it that nitrogen management is so challenging? For us to understand that, we'll have to take a quick look into the nitrogen cycle, i.e., how nitrogen behaves. What I've done here, I've animated into a very simplistic version of the complex nitrogen cycle. We all know that worldwide, nitrogen is applied as a very important nutrient to the crop using either mechanical applicators or hand application across the field. Now, there are two very popular sources of nitrogen that are applied worldwide, either ammonium fertilizer or urea. Now, what happens when you apply the fertilizer? Some of this application may be lost due to volatilization in the form of ammonia gas. Now, other application translates into a more favorable form into ammonium ion, which could also happen by a fixation of nitrogen, which is readily available in the air by leguminous crop or leguminous plants, as we all know, which is when taken by the plants start to show into a crop response. Now, some of this could be immobilized into organic matter. Some of it could be changed into nitrite, which could be immobilized or changed further into nitrate, a form that is favored by the plants. And notice there's a downward arrow because some of that could be lost. Now, there's another loss pathway or mechanism which is of great concern when we talk about the environment, such as NOx, the N2O, the NO, or NO2. And of course, there are losses due to runoff and leaching as well. Now, in this simplistic version of the nitrogen cycle, I am not incorporating nitrogen from industrial sources or vehicular sources or atmospheric deposition. I'm totally talking primarily what we do in terms of management in our farm fields. So what's highlighted here in red are the three major nitrogen loss pathways: volatilization, or losses in the form of emission, such as NOx, and losses in form of nitrates through the soil system. Okay. Now, if these two popular sources of nitrogen leads to so many potential losses, why not we use a different form? So here's a list of different forms of nitrogen that are available. I asked my graduate student to collate a list for me together, and it turns out that we have quite a few choices. And this is not even a comprehensive list. There are other organic forms of nitrogen in protein form and amino acids that are available in soil. That's not part of this list here. It turns out that there are only 2 plant available forms. So we're stuck. No matter what we use, we have to convert them into nitrate and ammonium, which are plant available forms. So then the key question is, again, how do we manage nitrogen for our crop production? Very simple sounding question, but full of. So let's take a look in the past. My predecessors across the U.S. at major land-grant universities. I'm based in Colorado, right here. And like other major land-grant universities, Colorado State University also have a network of agricultural experiment station distributed all over the agriculturally important areas in the state. Now, my predecessors will go to these ag experiment stations and establish small plot studies at multiple locations across multiple years to study crop response to additions of different rates of nitrogen. They will then bring this data back to calculate what's the best nitrogen rate for different crops in different parts. So here's a very simple calculation of the optimal rate of nitrogen. You have nitrogen rate in pounds per acre on the x-axis. You have grain yield or production or crop response on the y-axis in bushels per acre. And then you have a scatter of observations coming from different years or different locations together. Then, of course, we do a simple regression analysis to find out where the maxima is, meaning at what nitrogen application rate the crop responded the most. That's the maxima. And for a number of reasons, we have always come up with a recommendation of the optimal range, which is safer to apply for agronomic reasons, for economic reasons, and for environmental reasons, right? But notice this leads to a recommendation equation. For example, in the state of Colorado, this is a commonly used nitrogen rate recommendation that has been developed over the years, right? It leads to one and only one recommendation, i.e., the entire farm field needs to receive an average nitrogen application rate. Well, here's one example. This is a center pivot irrigation field in Colorado. An average application of nitrogen across the field would mean one size fits all approach. Okay. Now this is how we have managed nitrogen and made nitrogen recommendations. 30 or so years back, when global positioning systems or GPS became available for civilians, that totally changed how we do agriculture today. Agriculture is highly location based. Each and every part of the field matters because it has its own unique properties, soil and crop properties, and potential of how much it can produce from each and every part of the field. And available for last 20 or more years that allow us to quantify those changes in soil or in crop production. Yield monitoring is a very good example. Here's a simple animation of a combine equipped with yield monitor harvesting crop, and every second it's documenting how much grain yield was captured every second, 186 bushel, 180 bushel, 162 bushels, and so forth. Let's put this data back to where it came from. Okay, so here you have the entire grain yield map for that particular center pivot irrigation system field. Now you can tell right away, looking at the different colors of grain yield pixels across the field, that grain yield is not uniform. And no surprises there, because we have been looking at the yield maps for the last couple of decades. You bring this data into a simple software and run some simple statistics. It will tell you that the average grain yield for this pivot was 180 bushels to an acre. Okay. Now, we could do some very simple statistics or analysis that could really provide an insight into the data. For example, because we have grain yield data, pixel by pixel by pixel, wouldn't it be nice to know how many pixels in this field actually matches the average production? Okay. It turns out that in this particular example, about 2% of the field represents the average. In fact, we went plus minus 1% of the average yield, and it does not change a whole lot. About 10-12% of the field represents the average. In fact, to illustrate the point on spatial variability that happens in every field or in most fields, we went back to do an estimate on plus minus 5% of the yield. It turns out that we still do not hit the 50% mark on this field. What's the take-home message? Well, the take-home message here is that if we choose to make an average application of nitrogen across our spatially variable fields, then obviously some parts of the field will be over-fertilized, and we don't want that to happen. And other parts of the field may be under-fertilized, meaning we're not even providing enough nitrogen to that part of the field for highest potential. We don't want that to happen. Average is not necessarily the best in our management scheme. Okay. As you can see in this particular example, the center pivot irrigation field, the reflectance coming off from the field tells us that there is tremendous variability in our field. Now, how do we make nitrogen management decision? Historically, we have employed soil testing mechanisms. Okay, so we go out to the field, divide the field into grids, and let's say we take one soil sample for every 25 acres. Okay, you go out, grab a soil sample, send it to the lab for analysis, and then you prepare a variability map. Now, depending on at what intensity you sample your field, you may have a very different output. So in this example, we are taking one soil sample for every 10 acres. All right, you send the lab for analysis, and you get a different output. In fact, you can continue to sample at higher intensity, and the result looks very different. Okay, so there's one enigma that at what intensity we should be sampling the field. Okay, but one thing is clear, that as you take more soil samples, you're spending more time, you're deploying more labor, and you're spending a lot of money. So the question we had, is there a better way of capturing spatial variability so that we can make better nitrogen management decisions? A logical question, right? It turns out that there is a way that we can quantify variability in soils. In this particular example, this is management zones delineated, looking at the differences in soil color. You can see that on the left side of the field, it's a much lighter color classified as low management zones. And on the right half of the field, much darker color of the soil and is classified as the high management zones. Let me share with you some of our experiences in developing management zones in the state of Colorado. We have looked at 4 different techniques. I'm just going to give you some details of one of the. Okay, so here's the center pivot irrigated field. We go out and The very first data layer that we have used is the bare soil imagery. Now, bare soil gives you a measure of organic matter distribution across the field, which is a very important parameter for grain yield. It also gives you a flavor of distribution of soil texture and hence distribution of soil moisture in the field. And in fact, one of my graduate students looked at multiple other soil properties that you can get a distribution or flavor of across the field. Recently, during the time that we could take flights, I was flying and getting ready to land at the Denver International Airport. And I had a window seat and I was looking down and I saw this. I immediately pulled out my phone and took this picture. Let me zoom in a little bit. And I noticed that there was a creek running through the landscape. And I can illustrate right here. And at some point of time in history, I don't know, 50 years back or 100 years back, it got bifurcated into two streams, okay? And notice that did not happen overnight, of course. And in this process, okay, it went through slowly but surely into a widely apart two streams, right? My point here is that this happened over 50 to 100 years. And that signature in the soil is visible even today, as you can look at the two circles, one half circle and one full circle. The take-home message here is that bare soil image is a very potent data layer that can provide us tremendous amount of information and has value for our crop management. The other data layer that we used is field topography. You can measure field topography in a number of ways and can bring this data into a GIS platform and construct an elevation map. We all know that as we go from summit to side slope to toe slope, there is a significant change in the productivity potential. Now, once you have this data, you can also create some derivatives. For example, you can create an aspect as well as slope map. Now, slope map is kind of easier for us to understand why I want a slope map, because it then gives you a measure of how the water might flow. But aspect, that's all the red areas that are shown in this figure right here, tells you how much solar radiation or sunlight is impacting that part of the field, primarily the south-southwest exposure of the field. Okay, why is that relevant? Let me show you a picture. They say that picture is worth 1,000 words. This is my subdivision, and the road is running east-west. And so what you're looking at, the side of the road, it's facing south-southwest. So it gets a lot of sunlight, okay? Now, 30 days after the snowstorm, see what happens on the side that is exposed to north and northeast. There's still tremendous amount of difference in the temperature. And if you're still wondering how is that related to crop production, well, again, I have another picture to share with you. This picture was taken by one of my graduate students, and it clearly illustrates that exposure to sun and the difference in the temperature has a very significant influence on crop, right? And so along with that elevation map, you can also estimate water as well as water pooling map, just from one data layer, i.e. And here's the third and the final data layer. Back then, when we didn't have access to 5, 6, 7, or 10 years of yield map, we said to ourselves, what could be a good data source? And after much brainstorming, we came up with the idea, why not we tap into what farmer already knows about their field, about their farm, based on years of experiences. So we actually we will go to the farm, sit down with the farmer, give the pen tablet, and have the farmer draw different polygons in their field boundary, signifying parts of the field that are low producing and other parts of the field that are high producing. We'll bring that data back to the lab and stack them up, bare soil imagery, topography, and farmer's experience, and then use a statistical procedure to delineate management zones as it is shown in this field right here. Okay, so 3 management zones, low, medium, and high. I don't want to suggest that every field has 3 zones. Some have more, some have less, and also they may not be contiguous. Let me share with you some of the results that we have observed over the years. What I have here on the x-axis are low, medium, and high management zones, and on the y-axis I have grain yield or crop response in tons per hectare. Okay, so if we do a good job in really measuring variability in space and classify the field into low, medium, and high zones, our results indicate that we can do a much better job in terms of managing nitrogen in low production area, in medium production area, in high production areas. In fact, some of our research has shown that you can significantly reduce N application or do precision nitrogen management, i.e. applying the right input, which in this case is nitrogen, at the right time, at the right place, in the right amount, and in the right manner, that you can continue to increase your grain yield and cut down on your nitrogen losses. This study was done many years back. In fact, we also looked at the economic feasibility. Does it pay to make precision nitrogen management? And it turns out that you can have an advantage of $7 to $12 per acre compared to blanket application of nitrogen across your entire field. More recently, we have continued this work over the years. We have increased our level of precision management. So let me share with you. So a solid bar graph will show you uniform nitrogen management, one size fits all. This is nitrogen management based on management zones. Okay. This indicates nitrogen management based on crop sensing or proximal sensing, whatever sensor you want to use it. And then even a higher level of precision, doing crop sensing within each management zones. Let's take a look. What we have found that as we increase a level of precision in managing nitrogen, i.e. applying the right time, right rate, right place, that we can continue to push the envelope in terms of increasing nitrogen use efficiency. All right. This is all done on farm fields. And so when I was showing this data to one of our collaborating farmers, logically the farmer asked, okay, so what did you do to my corn yield, right? What happened to my yield? Right? So of course, that's a very logical question to ask. So we also looked at the yield. And of course, across all 3 site tiers, and we have done it for a number of site tiers, this work, we did not take a hit on grain yield. If we apply the right input at the right time, at the right place, in the right manner, and in the right amount, the 5 R's of precision agriculture, then the chances are you can maintain your production, continue to increase nitrogen use efficiency, and perhaps make more return to your pocket. Sally asked me to talk a little bit about the sustainability aspect. I know nitrous oxide emission or N2 emissions is a loss that may happen from our fields. And so we looked at different management schemes of nitrogen. If we're doing blanket application of nitrogen across our fields, we may sustain a N2O loss anywhere from 5 to 6 kilograms per hectare per year. Now, when we compare that with precision management, what was really an eye-opening experience was that we can significantly reduce our emissions. Okay, and that's why I moved my axis to the top. Significant reduction when you manage nitrogen based on management zones versus remote sensing within each management zones. We were really positively surprised that these reductions in the emissions could be as high as 50 or more %. This is a welcome news that we could site-specifically apply nitrogen or precision nitrogen management, right input, right time, place, amount, and manner, and have a very positive outcome in terms of production, in terms of efficiency, in terms of losses that may happen on our farm fields. So in summary, nitrogen indeed is a very important nutrient, agronomically speaking, or environmentally speaking, or economically speaking, right? There is tremendous amount of spatial and temporal variability in our farm fields. This has been documented worldwide in small-scale farming systems or large-scale farming systems. And should we choose to do uniform management of nitrogen, i.e. one size fits all across the field, we need to be aware that in some parts of the field we're not applying enough, and in many other parts of the field we may be applying more than what is necessary. And when we engage in precision management of nitrogen, it allows us to increase our production, or maintain our production, or increase our production, enhances nitrogen use efficiency, significant possibility of increase in net dollar returns, and of course, we can do all of this in a sustainable manner, working with a environmentally sensitive input such as nitrogen. With that, I really want to thank TFI and all of you for listening to my talk, and I would like to open the floor now for questions. Again, thank you.
That was a lot of important information, and we've got some good questions in our Q&A box. Remember to either vote up questions that you're interested in hearing the answers to, or put your answers in the new box, and we'll keep publishing those as we go. A couple of things that I took away from the presentation is, something I hadn't seen before is the use of this bare soil imagery, and I've got some questions in the Q&A on that, but I'm also curious how we're going about getting that bare soil imagery. Excellent to see that we can see a $17 to $12 savings per acre when we implement some of these management practices, and tie that to up to a 50% reduction in nitrous oxide emissions to meet some of our environmental goals. So, Raj, are you got your mic working for us?
Yes, I am, Sally.
All right. So, Raj, we have quite a few questions here. I'm going to start with the bare soil one because that got 10 votes, and I was also curious about it myself. So the question is, by bare soil, are you considering the field has been tilled, and how well does the bare soil imagery work for no-till with differences in standing residue?
Yeah, that's a very good question because when you work in the area of remote sensing, it becomes very quickly very clear that anything that's not an object of interest, we call it noise. And so if our product is bare soil imagery and we have any kind of residue floating on top of the soil, it acts as a source of noise. And so that data layer, bare soil imagery, proves to be challenging in those environments. What I have tried, or our group have tried in past, is going back to SSA office and looking into the repository of data that they have. And many times we have gotten lucky in the sense that we were able to acquire imagery of the field of interest before the farmer had engaged in no-till conditions. And if that's the case, you could digitize that imagery if it's not in digital format, and then bring it into the system for the data layer. As I alluded to in my presentation, soil has a very long memory. It has a long, retention in terms of what happens in the past, continue to influence the output. And so that's one way. Of course, technology has progressed further. One of the hypotheses that my group is interested in testing, we have not tested that yet, is could we employ thermal imagery to look at the differences in temperature across the field to quantify that spatial variability that's coming from soil? Because what we have found in our preliminary analysis, that areas that have more residue tend to be cooler and tend to be highly productive compared to the areas that are sandier in texture, low productive, and tend to be slightly warmer. Now, this is still a hypothesis. This is something I would like to test, but we're not there yet.
Great, thanks. Next question I've got is the research based on irrigated ground in an arid climate? And was there data from any rain-fed systems used in your analysis at all?
Okay, that's a very good question. Thank you for pointing that out. Majority of the data that I've shared in my presentation here today is coming from irrigated ground. And because I've been fortunate in the way that some of our work has moved in many other countries, in many other environments, there have been similar work done in rain-fed environment. Now, rain-fed, it's a totally different system, as we all know, and things become a lot more challenging and harder to control when you don't know how much water will happen, precipitation may happen, at what time, and in what amounts. And so that makes it a lot more challenging. And under dryland or rain-fed conditions, there are several other elements that could be managed more efficiently compared to the irrigated environment.
Okay, thank you. Next up, we have which remote sensing technologies were most effective for nitrogen management in corn?
Wow, that's a I don't have a silver bullet for that. I think we continue to work with our existing technology to be able to address that. I know NDVI is very widely used, and many times I have mentioned this in my talks before, widely abused vegetative index. It does a great job in terms of quantifying biomass, but not necessarily quantifying differences in the greenness. It also has a tendency to saturate a lot sooner in the growing season, and so it fails to decipher nuances or differences in the crop canopy when the canopy comes to a closure. So there's multiple limitations with NDVI. A couple of my graduate students recently worked with several other vegetative indices, and NDRE, normalized difference red edge index, did a slightly better job compared to the NDVI. And so, that's a tough one. I can't really put my finger, Sally, on one particular index that could really act as a game changer. Now, I want to share with you that my lab right now is working on a suite of very tiny, inexpensive, cheap, passive, battery-less, biodegradable soil moisture and soil nitrate sensors the idea is that we could then distribute these next generation of sensors in our field in hundreds to be able to measure diagnostically how much nitrate is in the soil that allow us to do better nitrogen management. Now, we're not there yet. I know there are other groups like ours that are working on plant nitrogen sensor. So what I'm trying to share with you here is that I think in near future we'll have a totally new suite of sensors that would allow us to then work with multi-dimensional data set. The reason I say multi-dimensional because you have X and Y across the field, Z as in depth in soil, and time T. And so, of course, once we have these suite of sensors, we'll have to dabble with a totally new challenge. How do we translate these boatloads of data meaningful that allow us to make almost near real-time decision-making process?
All right. One last question. How and when did you say that you were soil sampling to determine the nitrogen needs?
So would you repeat that question, Sally?
When were you taking the soil samples for nitrogen needs, and how were you taking those soil samples?
Okay. So the data that I showed today was alluded to sampling that was done prior to planting. In spring in Colorado, that would be in the month of April, sometimes in the last part of March, depending on how the weather is performing. And we typically go down to 4 feet depth for collecting research data, but for the purpose of providing, on-farm demonstration, many times we look at what if we do only 0 to 8 inches soil sample data and 8 to 24 inches, which is quite commonly practiced in our part of the world.
All right. Well, thank you for the presentation today and your time for question and answers. We have some more remaining questions, and we'll be answering those over the next few weeks. So keep an eye on InfoAg's Twitter page and in your email for those. Next up, we have a presentation from Jeremy Wilson of EFC Systems. And after Jeremy's talk is completed is when we'll have the QR code up for CCAs. The session is for a full CEU, so we're not quite at enough time to put the QR code up just yet. So I'd like to welcome Jeremy to do his presentation.
Hello and welcome. I'm Jeremy Wilson, Senior Vice President of Field Data Solutions with EFC Systems. And thank you for joining us today on the webinar on the InfoAg Learning Exchange for a presentation titled, How Can Placement of Nitrogen Fertilizer Impact Productivity, Profitability, and Sustainability? I'm really excited to listen to what Raj has to offer here. It's kind of been chasing nitrogen, and if you've heard me speak over the last couple of years, I don't even pretend for a minute that I haven't figured out. So it'll be interesting to hear what he has to say. You've been listening to me the last year or two. I've been talking about changing the farm gate conversation. So I'm going to hope that you've all worked to make that change. And this little short segment I'm going to entitle Elevating the Conversation. And because I made another trip out, and as we were at the farm and at my ag retailer this spring as we were farming, I began to ask some questions. And I said, as a grower, what are you looking for? What are you after? What's your goals? And as it revolves around when you're working with an ag retailer and buying products and such like. And the first piece of feedback says, I want the best hybrids and variety at the lowest price. Well, thank you. That's kind of normal. As consumers, that's kind of what we've all been after. How can I get the best product or at the best price and the best services, you name it. The next one to come out is I want higher prices for the commodities I sell. I think you'd probably agree with that as a general rule, a grower's always looking to get another 10, 20, 30, 40 cents for a commodity, or maybe it's more than that. The next one caught me by a bit surprise. This is an ag retailer that has the inventory of the products I need when I need them. Okay, so the feedback I got is I've never not been able to get the product I needed, but sometimes not as timely as what I would like. And the last one surprised me the most: remote access to needed information. I found that really hard to believe. And, more than one of them said, I don't have to have a mobile app. I just need to get it where I can get it on a web browser. Maybe it's just where I can open up my phone and open up the internet. I like that best. And just go look and look at my bill, or I can look at what products we intend to spray or fertilizers we're going to spread. So I started diving in, and I said, well, then what's your goals? And I kind of got a mixed bag of goals, but I kind of summed them up the best I know how. The first one was increase productivity, reduce expenses, reduce risk, increase my competitiveness. The 4 core values you use, probably ag retailers that are on, you've probably heard your bosses say this 100-200 times. But when you really all sum it up, the overall goal is, how do I be more profitable? How do I increase my profitability? So I want to ask you, what role does your business want to play in that? Do you want to be the retailer or the salesperson that's got the sharpest pencil and the cheapest price, and we arm an entire sales force with a catalog or a price book and say go forth and conquer and try to win the price battle every time? I'm going to challenge you to say that there's an opportunity here to be the provider to help the grower meet his goals. Things like, can you help them manage their expenses? I'm not going to say you're going to be the cheapest ever. I don't want to say that. But what can you do to manage their expenses? Is there ways you can help them market grain more effectively? Maybe do a better job? I don't know. I'd say yes. If you're not in the grain business, that's fine. There's still opportunities for you. How about helping them have the available inventory when they need it? I think that's pretty important. Ultimately, this will help them improve their profitability. And I think that's really critical. In just 2 or 3 little things that we can do can make a big difference. EFC offers a complete suite of software tools to help you help your grower and make the best decisions we can make. At the center of all of it, improving profitability with data-driven outcomes is the center of what we do. And we're working for the farmer through the ag retailer to help him increase his profitability and be successful. Because ultimately, when he's successful, you're successful, and you get the opportunity to do business with him another year. EFC has a long history in the ag software or retailer software. Ernie started EFC Systems back in 1988. Through the years, he's had a number of different products like Vanguard Ag, Merchant Ag, Fertilizer, Ag Solver, even more tools and features. Maybe they'll deserve a new name now here in 2020. Merchant Ag is an ERP system specifically designed to address the unique aspects of an ag retailer, spanning all major departments. Things like accounting, agronomy, oil and energy, feed management, commodity and grain merchandising, employee mobility, and customer portal. The center of what Ernie makes us think about all the time is, how do we do the right task with the right device at the right location? So we got mobile tools, we got desktop tools, we've got tablet tools, you name it. We have a lot of tools, and a customer portal where a customer can get in and see the needed information that they need to answer a question or to do business with that ag retailer. On the Fertilizer side, it's a comprehensive field data management platform that centralizes all field activities while enabling other features like logistics, farm planning, subfield profitability. Yes, we handle the soil sampling and fertility management. We record field records. The big thing is managing work orders and logistics, and how we can streamline some of those processes. And as we integrate Merchant Ag and Fertilizer, that work order process even becomes more automated, and I'll hit on that in a little bit later. And then embedded within Fertilizer is the Ag Solver engine that is the center of driving this, changing the farm gate conversation, and now elevating that conversation by having advanced agronomic planning and farm planning and subfield profitability to really dive down and understand what fields are profitable. The other big part of that is that profitability visualization. Everybody knows that dry hill or dry corner or that low spot, or we all know those parts of the field. that aren't as profitable as they should be. But being able to visualize that and put real numbers on it and what it really you need in a yield increase or cost decrease to break even, I'm going to challenge you. That's going to elevate the conversation to a new level. So I ask you, how many have taken the time to sit down and work through a total farm operation and understand how many bushels are produced and what that cost is? I'm going to say I spent an hour, maybe hour and a half creating this. But as if you were my ag retailer and you had this report, you could come out to me and say, Jeremy, you're going to need an operating budget of about $600,000. From that $600,000, you're going to generate 34,000 bushel of soybeans and 92,000 bushel of corn roughly that you need to market. Today, the break-even price on that, $6.39 a bushel. On your soybeans, $3.82 on my corn. Yeah, there's probably some marketing opportunities right now for break-even on soybeans, $3.82 on corn. I probably need to do a little work. But the biggest thing that stands off to me is that working capital opportunity. I got $182,000 I'm putting out there on the line that I'm going to break even at best on and probably lose money. Odds are I might as well take that $182,000 and lay it on red in Vegas. I won't really do that, but that's basically what we're doing, and probably got less of a chance making money than if I go lay it on red. From that same report, we move into another really critical report as you work as an ag retailer working with the growers is shopping list. If I've taken this little bit of time to create these templates and these farm plans, I now know a shopping list of everything that I'm going to need to supply to that grower. If he does 100% of his business with me, or if he only does 1 or 2 or 3 of the products, I still know what he's going to need for that. You know, I'm going to need 348 gallon of a glyphosate product. I'm going to need 76 gallon of a Liberty product. If I'm doing this farm plan and doing profit planning in December, January, February, am I going to need to worry about having an inventory of Liberty yet? But that integration we have into ERPs, I mean, yes, we're integrated into Merchant Ag our own, but we integrate into others as well. The pricing and the cost on that is virtually real time. But the other thing that happens is when I call my ag retailer on March 3rd and said, hey, I just finished planting my Liberty Link soybeans, when do you think I'm going to need some Liberty available? Probably about 21 days. So I can open up some of the mobile tools that are available through Merchant Ag and see inventories and say, oh, wait a minute, I've only got 26 gallon of Liberty in my building here, but the facility 100 miles away has got 300 gallon. Maybe I need to get that transferred up there. You want to talk about elevating the conversation? If your customer calls you and says, hey, I'm going to start spraying Liberty tomorrow, I need to come pick my Liberty up, and you've got 180 gallons sitting there and you know he needs 76, I think you're ahead of the curve. Another critical part is just profitability and how we can look at that and begin to understand it. Like I said before, we all know those spots, and if you've heard me speak, I've said a number of times, 80% of my yield drag comes in the outside 120 feet of my field. That's one of the best visualizations I've ever seen of it, but that's as real can get. You know, we analyze at a farm enterprise level, but we also drill down into that 3 meter by 3 meter grid to understand that. We can begin the process of benchmarking now and understand what we're doing over time and over different variables and different things that happen out in the field. You know, I got the opportunity to make $50 an acre here. I feel pretty good about that. Don't know, you know, the yield there of 177, that might be stretching it just a little with the dry weather we've come through. But that was our plan. That's what we built it off of. That's what we started on. I can make some tweaks in real time if need be. But more importantly, if I go back to my ag retailer and say, hey, $50 is not enough, I think I want to cut my fertilizer bill, cut it back, because you know I just need more than $50 to pay some of my loans off or whatever they might need to go to, maybe a family vacation. So I'm going to cut the fertility bill, huh? Yeah. So yeah, that's $110 an acre. I get it. About 13% of the total cost of putting that crop in the ground. I could make the case that those areas where the profitability is reduced, maybe we look at a variable rate application map where we cut those rates back. But I can look at that grower and say, Mr. Grower, in that area that we're profitable, we're making good money, do we really want to take a chance that fertility could become the limiting factor to yield that impacts our overall profitability? Raj may tell us now that it's all going to be about timing and placement of nitrogen. I think probably that's a good possibility. Even with this understanding of distribution on all that, what tweaks and what changes can we make? Maybe we can cut some back there. What about that guy that just throws a fit because your chemical program is ridiculously expensive? Take this report out and say, well, Mr. Grower, your chemical bill's 23 cents of the total selling price of your crop. I think that's an elevated and different conversation. We're no longer talking about what's a gallon of a glyphosate or what's a pound of this product. Want to apply a fungicide? What if we add a fungicide to that and figure out a fungicide's about 4 cents a bushel? Mr. Grower, is there opportunity here to gain 4 cents a bushel? I think there probably is. Why don't we give it a look? As we watch that distribution yield, we can see that, you know what, I'm probably not going to save myself to prosperity if I need to reduce my cost by $546. But if I need to reduce my cost by $26, there's probably some tweaks and things I can make to make a little more profit off of that field. Everyone always says when I talk to them, oh, it's just the soil type. Well, if you want to look at that too and have that discussion and elevate that conversation with that grower, go right ahead. If you look at this, yes, I do have one soil type that is more profitable every single year. But if you look at how that distributes out across the field, I don't see that line up exactly with my profitability. Maybe there's other factors that's affecting my profitability more so than just a soil type or soil conditions. At EFC, we understand that business requirements are not static, and our team believes that software must evolve to meet the demands for today while exceeding the demands of the future. And our mobility functions and other things that we're bringing, the new features, we're working really hard to connect both your fields and financial solutions into a single tool, and bringing new functionality to help you have a relationship with that grower where you partner in their operation to increase their return on investment and their profitability. Our promises to you, our vision is to meet the demands of today and develop functionality for tomorrow, which leads to improved processes and better decision making. Our business passion is to make your business better and more efficient, and working as a long-term strategic partner. I don't need another customer to come buy Fieldalytics or Merchant Ag or buy the whole suite. I want a partner. I want someone who wants to work with me to help understand what we can bring in functionality and tools to make you more successful working with that grower and bringing more success to that grower. We have a very wide group of people that has agribusiness experience from a wide range of areas of agribusiness, and we put that to work every day to optimize the service and the value you can bring to your customers, because at the end of the day, empowering agribusiness professionals and farmers with information to succeed is the core of what we do. If you'd like to join us in elevating that farm gate conversation, feel free to reach out to info@efcsystems.com. Thank you for taking time to join this webinar, and with now, I'll turn it over to Raj. Thank you.
Thanks again for joining us today and for our sponsor support. Please visit infoag.org for more information about our webinar series lineup and to register for InfoAg Live in December.